Hello everyone, welcome back to the channel. I'm Sanket Singh, and in this particular video we are going to continue our discussion on the Git Advanced series. In this particular lecture we are going to discuss some more important Git concepts, including concepts like stashing and all, and we will take a very in-depth dive in order to actually understand that what goes behind the scenes when you are in different use cases, what use cases can occur when you are managing things with Git, and how you can actually solve them. All of these things we are going to actually talk about. This particular video is a part of a longer 3 to 4 video series on Git. The two previous videos are already up on the channel, so if you have not yet watched, please go and watch that. That is going to give you a very good perspective on how Git works, because I have talked there about how the Git internals work, what data structures internally Git works with. We have talked about blobs, trees, hashes, all of these things, and taken a very good introduction to Git as well. Now is the time to actually see some of the advanced concepts around Git, right? So without any further delay, let's just start. But before we actually start with the video, if you have not yet subscribed to the channel, do consider subscribing to the channel, because we are going to bring some very awesome content regarding tech and software engineering on this particular channel. So let's just start. So before we move forward, I would like to tell you about algocamp.io. So if you are someone who is willing to learn programming from scratch in, let's say, Java or JavaScript, right? Or if you are someone who is preparing for their interviews, then algocamp.io can be one-stop solution for you, right? You can see on algocamp.io, there are a bunch of courses regarding data structures and algorithms in JavaScript. So let's say if you are a front-end engineer who is aspiring to become a front-end engineer and preparing for interviews where you will be asked questions in DSA and the main language that you use is JavaScript, then this can be a really good course for you. Apart from that, you can see there is a dedicated course on mastering Java with backend in Java in Spring Boot along with system design, right? You can see all of the concepts regarding basic Java, then data structures and algorithms in Java, and tons of problem solving is actually present there. You can see more than 400 problems you are going to solve in this particular batch. There is going to be more than 300 hours of hybrid content. Some content will be coming recorded, some content will be coming live. You can see we are going to talk about all of the important data structures, including segment trees, heaps, graph algorithms, dynamic programming, all of the things. Apart from that, there will be additional computer science fundamentals like computer networks and database management system as well, right? Apart from that, there will be dedicated lectures on Spring Boot, that how you can actually make good backend applications with Spring Boot. And there are going to be more than 10 projects that you are going to do actually in this particular batch. You are also going to be introduced with low-level design, with different design patterns, as well as high-level design, where we will talk about problems like how you can design a system like Uber, or how you can design something like URL shortener and whatnot. You can see the price of the course is 4,200, and this is something that we have kept very affordable. And in fact, if you will use the coupon code ALGOCAMP500, you will get 500 instant off on this particular course. You can see the instructors for the course is Ria Bansal, who is actually a software engineer at Microsoft. She has previously worked with Flipkart. I'm also going to assist her in this particular course. So you can see the mentor side of the course is totally sorted. The price we have kept is very competitive, considering that you are going to learn data structures and algorithms, system design with design patterns and high-level design, as well as backend development in Java, right? So this is one power-packed course that you can definitely opt for. So you can check out algocamp.io for more such interesting stuff. I have made a dedicated video on what you can expect with this Java course and overall in algocamp.io. You should definitely check out that. I will link all of the things in the description section below, so don't forget to actually check that out. And now let's just move forward with our current video. So now let's start the discussion on the topic of stashing, right? So what is a stash? So technically you can assume stash is kind of like a safe. Safe means a safe case, right? Where you can save a bunch of your uncommitted stuff. Let's say you are making changes to some config files, right? And you don't want those config files changes to be committed, right? But you want to keep your working directory clean, right? And you want to make sure that nobody commits that, but you don't even want to discard your changes. You want to keep those changes safe somewhere, but you don't want to commit that. In those kind of cases, stashes are kind of like a safe where you can store these kind of data. So let me give you an example. Where did I use Stash? So back when I was working with InterviewBit, they were having their own backend repository in Ruby on Rails, right? So what happens in Ruby on Rails, the external libraries, third-party libraries, if you have to install, they are called as gems. Like in the world of Node, they are called as packages. In world of, let's say Ruby, they are called as gems. Okay, third-party packages and everything. So what happened was there was a gem. There were a bunch of gems, 2, 3 gems, which were having some problem in a particular version in working on our local system. So for our local system, we had to configure a particular version, and but that particular version that works on the local was not compatible with the broad environment due to some issues. There might be some legacy issues that they were having. Okay, in those cases, what we had to do, what we had to do was we had to, when we are actually setting up the project on the local, so even setting a project on the local was done in 2 ways. One was a Dockerized way, where you actually get a kind of like a Linux container booted up on your system. If you go via that way, then the same production dependency can work. But if you're not going via Docker setup and you are like locally setting up it like raw, then you have to change a few things in the gem file. Now, a lot of times, a lot of intern, what they used to do was they used to do git add all. If you do git add all, you try to make changes in the gem file. And if a gem file change is detected in a PR, or let's say in a feature request, then that feature request gets cancelled because gem file changes were not expected. So what was recommended was, if you are not setting up things around Docker, then try to make sure once you do the setup complete using the gem file, you stash the gem file, because you don't want the changes to go in the next commit and you don't even want to lose it. So it was kind of like a safe area where you can just keep the changes. Whenever you want those changes back, you can bring them from a stash. So you can say that stash is like a safe locker. You put some changes there, and you can keep on putting changes there. Every change that you put in the stash can give you kind of like a tag or a version, and then you can bring back changes from the stash. One thing that we need to ensure is that, or keep the thing in mind, is that stashes are not commits. That means they are not technically your actual version. They are just some bunch of code that you want to keep safe and you don't want to commit. I hope the basic understanding of stash is clear to everyone. Now let's say if I do git status, everything is cool. Let me do ls to see what all files we have. We have a readme.md, we have a code.js, we have node.txt. Let me make a new file. Let me call it as index.js. And let's say this is going to have console.log. Okay. Cool. Now if you do git status, once you do git status, you can see in your working area, the untracked file that you have is index.js, right? Now let's see things in action. Once you try to do a, let's say now you don't want this index.js to go in the next commit. Okay, let me make even one more file. Let me make one more file, vim. Let's say config.js. Okay, I'm just making random files. Okay, now if you do git status, so now you must be having 2 files in the untracked area. Now let's say you want to add config to your next commit. Okay, so git add config. Okay, if you do git status, now there is one file which is currently in the staging area, one file which is untracked. Always, if you want to make sure that you remind yourself that what is a working directory, what is the staging area, what is the repository area, always just say one thing to yourself. The things which are definitely going to be the part of the next commit are in the staging area. The things that might be part of the next commit are in the working area. And the things which are part of the previous commit are in the repository. You can say that, right? Now let's say if you want to stash something, let's try the commit command git stash. The moment you do git stash, you can see it says saved working directory and index state work in progress on master added code. Let's see. If now you do git status, can you see one thing? Your config.js, if you do ls, your config.js is now no more present. Your index.js, which was currently not getting tracked by Git, is still present there, but your config is not present now. If you remember, we had a config.js file and we added config.js file here. But let's say now we don't want it to be the part of the next commit, but we still want to save it somewhere safe so that we don't lose the changes, because the untracked file changes, so you can lose, right? But these changes are hard to lose, but you don't want it to be the part of the next commit. So now if you do the command git stash list, you can see there is a stash named @0 whip master added code. Can you see this is a stash here? Okay. Press Q to exit out of the prompt. And now what has happened is your config.js is safely secured in a safe area. That is the stash. If you want to bring it back, what you can do is you can say git stash apply, right? Then the moment you do git stash apply, then whatever is the last stash will be applied. So you can assume that the stashes are maintained in kind of like last in first out stack, right? You must have heard about the stack data structure. So stashes are maintained like that. So whatever is your last stash, you can apply that. Okay, I will also show you that how can you apply manually a particular stash. Okay, so for the timing, if you do git stash apply, now you can see the moment you do git stash apply, your config.js is back. See git status, see config.js is back. If you do git stash list, you can see the stash is still stored there, but you have applied it back, right? So this is the meaning of stash. So again, let me repeat. If let's say there is a piece of code that you want to be safely stored somewhere, but you don't want it to be part of the next commit. So what you're going to do, you're going to add that particular file and just do git stash. Just write the command git stash. What it will do, whatever is there in your staging area, it is going to create a stash out of it. Stash means it is going to create a new locker for you and store all of those changes inside a locker. If you want to bring back all of the changes from the locker, you can do git stash apply. The git stash apply command is going to apply the last stash that you saved. If there are multiple stashes, the last stash that you saved is going to be applied here, right? And you can have multiple versions of the stashes. I'll show you that how you can do that. But I believe the basic meaning of stashing a particular piece of code is clear to everyone. Now let's try to create multiple stashes. Okay. So currently if you do git status, you have config.js. Okay. Now let's do one thing. Let me commit it. Created only single stash. Okay. Something like this. So I have committed config.js file. Okay. So if you do ls, you have config.js committed. Now let me make some more changes to config.js. Okay. Let me add a few more changes to config.js. Console.log changes after stash 0. Okay. I added this change. If you git status, you can see that there is an untracked file and there is a tracked file in the working directory which is not staged. Okay. Now you want to create a stash. If you want to create a stash, let's see. If you just directly do git stash, it says it created a new stash. Let's see. If you do git stash list, you can see there are two stashes. See, stash 0, stash 1. Okay. If you want to see what data has been stored inside a particular stash, you can say git stash show stash @ you can give the stash number. So if I want to see the first stash, you can see inside config.js file, there is one line that has been inserted. Okay. If you do git status, you can see the changes that were going on inside config.js is technically now stored in a stash. Okay. Now let me make one more file. Vim new file.txt. Okay. And now here I'll do, this is a new file. Okay. Now if you do git status, you can see now you have two untracked files. Now there is nothing in the staging area and there is no file in the untracked region, which was already in the staging area. If now you do git stash, you can see there are no local changes to save. So first thing that we can learn from this exercise is that there can be multiple stashes that you can create. Stashes are not going to be created for untracked files. They will be only created for the changes that you do in a tracking file. How do you track a file? Either you add that file in the staging area. That's how you start tracking a file. Or there is a file already in the staging area which has some new changes. That is also a tracked file, right? Okay. So now let's see git stash list. Now see, there is only two stashes. Okay, cool. Now let me make one more change in the config.js file, vim config.js. Okay. Now you can see because the changes we have stashed, it is not having that particular change. And let me add a new line, console.log. This change is after stash 1 was created already. Okay, something like this. Now if you do git status, you can see there are two untracked files. So if you will try to do stashing for these two untracked files, nothing will happen. But if you will try to do git stash, config.js is a tracked file, it will store the changes. So if you do git stash, you can see a new stash has been created. And if you do git stash list, there are now 3 stashes. Now, moment of truth. Now, if you do git stash list, the stash 1 and stash 2, if you carefully see, these two stashes have changes of the same file config.js. Now, whatever stash you want to apply, you can manually apply. So if you do git stash apply, then whatever is your last stash, only that will be applied. Now, what is your last stash? You can see the last stash is this, only this stash will be applied. Okay. But if you do git stash apply and you mention a particular version of the stash, for example, stash @1. Now your last stash is not going to be applied. Whatever version of stash you have actually mentioned, that particular stash will be applied. Let's see. The moment you press enter, now you can see some changes are brought back in config.js. And if you print config.js, changes after stash 0 are there, right? Now, if you see stash list, still 3 stashes are there. Now let's try to apply the stash 2 changes. Okay. The moment you try to apply stash 2 changes, some changes are brought back in config.js. If you try to print config.js, now you can see the stash 2 changes are not actually added here. Can you guys see that? This is still having stash 0 changes. Why is that? Because you are trying to make changes to an already applied stash. This is not something that Git is going to allow you to do, right? This stash is not going to be applied. If you want, if let's say, if you now do git add config.js, you see git status, right? Now config.js is modified. If now you do git commit -m added stash 1, okay, and now you do git apply stash 2. Let's see if it applies it now or not. See, now there is a merge conflict. Why there is a merge conflict? Because in your config.js file, in the second line, there is a change coming from stash 1. You committed that change, and now you are trying to apply stash 2 on the same line. Git is now not able to understand how should it apply the stash 2 changes, because you are actually applying it on the same line. So if you do cat config.js, you will see this weird set of changes coming up, right? If you want to resolve it, either you can use the terminal, or I really like it to resolve it inside VS Code. Okay, so what I can do is I will accept, let's say, incoming changes. So incoming changes, you can see they are going to remove everything. If you do accept both changes, this is what we are going to apply, right? And now you do git add config.js, git commit -m, resolve conflict. Okay, you do git log, you have all the changes coming up, and now you do cat config.js, you actually have these changes coming up inside config.js. So I believe the concept around how do you store changes inside a stash, how do you apply it is clear to everyone. One thing to note is every time you create a new stash version, it is going to store some changes as it is. If you want to apply a particular stash version, then you can mention which version you want to apply. Just make sure that if you will try to apply two stash versions, which are technically going to make changes to a single line, then until or unless you commit it, it won't even apply. And if you start committing it, then it will start giving you merge conflict. So you need to make sure that once you start applying your stashes, you are actually safe. You are actually safely applying the stashes. Don't misuse this property a lot, because in that case, you will end up in a lot of merge conflicts that are created by you only. Now you might feel that this is not a very useful case, that whatever files are getting tracked, I'm only able to save the changes of those tracked files. What if you want to save changes of untracked files? So there is a command that you can do, git stash -- include untracked. The moment you do it, it creates a new stash. And if you do git status, your untracked files are gone. So if you want to manually mention that, okay, don't just keep the staging area or the tracked files in the safe region. Whatever is there in the untracked files, I want to keep that also. You can add this flag, and now you will be having a new stash. The moment you do git stash apply, your both of the files, because they were in the last stash, are going to come back, right? This is kind of like a very useful tool that you are going to use, because I believe storing the changes of untracked files make more sense, right? If you want to make sure that you add all of the files in the stashes, then there is a command git stash -- all. This will help you to add all of the stashes, but you don't need to remember all of these commands. You just need to remember the concept of stash. Whenever you have to do a stash, just Google it. You will get all of the commands handy in front of you, and you will be able to understand, okay, which thing I am actually storing inside a stash. So let's say now we have two untracked files. I don't want to add both of the untracked files. I just want to add, let's say, index.js. How can I do that? What I can do is I can do first git add index.js. This will add index.js in the staging area, just index.js. And then you can do git stash. So it will just add index.js in the stash. One more thing that you can do is you can say git stash. I believe you can do -- index.js. Okay. So for untracked files, let me do it like this. Sorry, include untracked. You can see the moment you do git stash -- include untracked and do git status now just your index.js file is actually added to the stash. Your new file.txt is not added to the stash. If you have multiple files in the staging area, then you can just directly do git stash -- this. You can see it was trying to search for index.js in the staging area. It was not able to find index.js in the staging area. That's why it was throwing an error, because index.js was in the untracked region. So if you want to you do things with untracked region, you do this and then do a -- and then the file name. That particular file only is going to be added to the stash. So this is kind of like pretty useful, right? That you can do. There is one more command that, as far as I know, you can use. There is something called as push, right? So let's say if you do git stash -- include untracked, and then you say, let's say, push new file.txt. I believe this is now not supported. Push is not supported, so no problem. As I said, you can just do -- and this is going to create a stash out of it. So just if you want to create a single file stash, you can just do a -- command, and that is going to help you to stash a single file. This is more useful, I believe, because most of the time you'll be having multiple changes, but you don't want to stash everything. You might want to stash 1 or 2 files. That can be really useful for you. Now, if you do git stash list, you will see there is a lot of stashes. Now let's say you want to remove some stash, because let's say you apply a particular stash. Let's say I do git apply, sorry, git stash apply. Right, so we brought back new file.txt. But if you will do still git stash list, you're going to get all the stashes. How can you remove a particular stash? Let's see. So let's say you can do something like git stash pop. It's kind of like a stack architecture. So the moment you do pop, now it says new file.txt is already exist, no checkout. So what's happening? So what the pop command is trying to do, it is trying to apply the changes of the last stash, but they are already there, right? So one thing that you can do is, let's say you can do git rm new file.txt. Okay, once again, what's the name? I believe we have to do so instead of doing git rm, let's do rm new file.txt. Let's remove that file altogether. Okay, if you do git status now, everything is clean. Now let's try to do again git stash pop. The moment you do git stash pop, you can see new file.txt changes came back and you have dropped a stash. Okay, see, if you do git stash list, you can see one stash is gone, the 5th stash is gone. Okay, if you do git stash pop again, now you can see index.js is also back and your 4th stash is gone. So if you want to apply the changes of the stash and immediately remove them also, then you can do git stash pop, right? Now let's say you don't want to apply the changes and then you just directly want to remove it. If you want to remove the last stash, you can do git stash drop. You can see this is not going to apply any changes. This didn't apply any changes, but it is going to remove a stash. If you want to remove a particular stash version, just copy that version and say git stash drop that version. It is going to drop that particular version and not apply any changes. So git stash list. You can see now the top one is actually gone and they have renamed themselves, right? So if you want to stash, like remove a particular stash and apply the changes also, you can do git stash pop. If you want to remove a particular stash and don't apply the changes, you can do git stash drop. If you want to remove everything in the stash, you can do git stash clear. It's going to remove everything, I believe. If you do git stash list, there is nothing in the stashes. All of your changes are actually gone. So this is how you can actually do removals of the safe area that you have done inside Git. Now let's say we created a stash. We do git stash. We created a new stash. Sorry, once again, let's do git stash minus minus include untracked. Okay, now you do git stash list. Okay, now you can see the stash message. This is not very useful. What this stash message is actually picking is your last commit message. It just tries to pick your last commit message, and it's not very useful, right? Because after the commit, maybe you have made a lot of changes and you're just stashing a very specific file. Then your commit message might not be very useful in order to actually identify what is actually stored inside the stash. In that case, we might want to rename or give a label to the stash. So if you want to give a good message to your last stash, you can say git stash save and you can give a message added index and new file. Okay, the moment you do git stash list, now you can see nothing is actually coming up, right? So what wrong we did here? Let's see. Technically, the moment you do git stash, do git stash include untracked files, and then you do git save, it should have updated the log, right? But technically it is not. What might have gone wrong? Okay, so let me show you one thing. Let's say we create a new file. Okay. And now I want to create a stash of it. Let's do git status. You can see code.cpp. Now, if you will just do git stash, it will create a stash using the last name. If you want to create a stash with a particular name, you cannot do it like you did git stash and then you updated the name. Instead, what you have to do is, while creating a stash only, you say git stash save. First of all, you do minus include untracked. Then you say save, saving code.cpp. Okay. Now you can see it says sub command wasn't specified. Push can't be assumed due to token save. 1 second. Let's do one thing. Let's do git add code.cpp first, and then do git dash save saving code.cpp. Let's do this. And now you can see it has created a new stash, and you do git dash list. You have saving code.cpp, right? Okay. Now, if you do again a new file, echo new file.cpp, for example, and I believe what you can do is you can say new file.cpp, and after that you can pass this flag. I believe this should actually save with this particular message. Yep. So you don't need to, if you have anything in your untracked region, then this flag minus include untracked should go after this. Now if you do git stash list, you can see saving new file.cpp came up, right? So you can see the stack like architecture, one above another. Last time we were not able to understand that what is the latest stash. So your latest stash is actually the stash 0 that you have. So when you actually remove it also, then the stash 0 is the latest stack that you have. So by having good naming convention, you will be able to identify. Previously, when I was listing, we were not able to identify whether the last line is having the latest stash or the 0th line is having the latest stash. Now, because we are giving good stash messages, we will be able to identify, okay, what we did in a particular stash. This is technically a cool thing to go for. Yes. So let's say if what I want is, there is a new file. Okay. Now I want to add this file to my last stash. What can I do? So as far as I know, you won't be able to do it directly, but you can technically do a hack here in order to do it. What you can do git stash pop. The moment you do git stash pop, it is going to bring the changes of your last stash. If you do git stash list, you can see your last stash is now gone. And now you can create a new stash. If now you do git stash list, then your last stash has been updated. So this is one way in which if you want to add changes to a last stash, you can do it, right? This is kind of like helpful if you don't want to create multiple stashes, but I guess this is supported. Like you have to algorithmically handle how your stack is handling all the stashes and at what point you want to actually make the corresponding changes. Now there is a very interesting use case that I would like to tell you about commits. Now if you do git log, you can see these are all the commits that are coming up. This is the latest commit. A lot of time what happens is you forget to add a bunch of files in your last commit. Okay. So let me tell you a few things around LinkedIn. So in LinkedIn, we used to have a one commit theory. What is one commit theory? One commit theory says that every feature that you are building should be done in one single commit, right? You should not have a chain of commits that you are pruning later. I'll also talk about how you can prune a bunch of chain of commits, but that generally was not recommended at LinkedIn. So at LinkedIn, what people used to do was people used to create their own branches, do stuff there. And then when they have to actually update their commits, they don't used to make another commit. What they used to do, they used to amend the commits. Again, it's a philosophical theory based on company to company. No practice is the best. No practice is having any problems, because internally, as far as I remember, LinkedIn was having a wrapper over Git. So it used to take the backups of the changes. So they were not worried about what if I want to go back to a particular change, but they want to keep the commit history clean.
So what they used to recommend was, let's say you have already committed something and then you created a new file. Okay, you created a new file or you created changes to some other file. Okay, now you can see git status. You have a new file. You do git add change.txt. Okay, now you don't want to create a new commit. You want to add change.txt in the last commit only. Okay, so how can you do it? In order to do this, there is a command called as git commit -- amend. Git commit -- amend, and then you can give, if you want to update the message, you can, I guess, give the message. Otherwise, the moment you do git -- amend, it is going to open the editor in front of you. If you want to make any changes to the commit message, you can do that. I don't want to make any changes, so I'll just save it. And now if you do git log, you can see no new commit has been added and the file change was added in the same commit here, right? So this is a very useful tool, git commit -- amend, right? This helps you to not only keep your commit history clean, but a lot of time what happens is you were trying to make the final commit change and you forgot, let's say, a one-liner change in some documentation, or you forgot one-liner change in readme. So making another commit for saying fixing readme or fixing this doesn't look that great. You can amend your last commit and push the changes. All of the things will look way cleaner than expected. So one thing to note is that once you make changes, let's say once you created a commit, it will be having a commit ID. Now you want to amend a new change in the previous commit. It's not like the same commit is changed, because commit is an object. It is created by the commit message, timestamp, changes and everything, right? So timestamp is never going to be same. So it's always going to create you a new commit object with a new hash SHA-1 ID, right? So this is something that you have to keep in mind, that whenever you actually amend something, you actually create a new commit SHA-1 altogether out of it. Now let's say that this is the SHA-1 ID after the amend. This is the SHA-1 ID before the amend. Okay. If you do git log, you can see the after amend ID is actually present here, right? There is something called as git reflog. I'll talk about reflog later, but let me at least show you. The moment you do git reflog, now things will start becoming interesting. In reflog, you also store the amend. You see, this is the amend ID, amended ID, and this is the previous ID. So technically nothing in git is actually lost. Nothing in git is actually lost, right? You somehow somewhere can track which commit was there on which you amended. Let me make another amend. Okay. Let me make another amend. Okay. Now you do git reflog. Now you can see there is another amend here, right? This was already an amend. Then we had another amend. Now we have another amend. We did 3 amends, right? So a lot of time, some teams might refer to this reflog. I'll talk about this reflog, that what reflog is in detail. For the timing, you can understand it's also kind of like a log history, but a bit more in-depth details you have. I'll talk about what is that head that is represented there. But my point being that nothing in Git is actually lost. Somewhere down the line, the changes can be fetched. It's just that how Git manages it is very clean. Amend gives you a sense of satisfaction that you have changed the previous commit only, but technically you have not. It is still considered as an incremental change only, but it doesn't affect your corresponding version. So that's something that you can actually use in order to keep your commit history clean. But still, if you want to go back to a particular change, you can still go back, because as I showed you, the changes are still stored incrementally. What is reflog? We are going to discuss about it later. Now let's start the concept discussion around branches. Okay. Now branches, I won't say is the most, or I won't say it's the least understood concept. People understand the concept of branches well, explain it well, but with a slightly less accuracy. A lot of time when you will ask someone that what is a branch, they will consider branch as a timeline. Consider that this is your master timeline where you are actually making changes. And then if you ask someone that what is a branch, they will consider it like a parallel timeline that you are preparing along with another branch. Then some another parallel timeline altogether. People consider branches to be kind of like parallel timelines of your code. For understanding and visualizing, to be very honest, for understanding and visualization, this understanding is good. There is no problem with that. But if you go to the technicality of branches, branches are technically not your parallel timeline of your piece of project. They are just simply one thing. Pointer to a commit. They are just a pointer to a commit. That means technically, I believe everyone knows how a commit object looks like. This is how your commit history might be going. And because it's a directed tree, right? You know that structure of your commits is actually a tree. The branch just acts as a pointer to a particular commit. That's it. Nothing more, nothing less. Branch is nothing more, nothing less than a pointer. So technically, when you say the word branch in Git, it's not a parallel, I would say, timeline of your code with respect to some other branch. It's just a pointer to a commit. That's it. That is it. So technically, like a lot of people, so in order to create a branch, what you can do is a lot of people will tell you this command git checkout -b and then say a branch name. Okay, using this command, you can create a branch. So actually, when you use this command, it does nothing, but it just creates a new pointer to the particular commit that you are at, right? It just creates a new pointer on that commit. And then whenever you start making another commit, it just shifts that pointer to the new child commit that you are creating. This is the reason why if you have a commit, you can directly convert that commit into a branch as well. I'll show you that how you can do that. But one thing that you need to always keep in mind that when you consider the concept branch is not a parallel timeline, or it's not a complete set of commits that makes a branch. Branch is just a single pointer to a commit. So you can move that pointer here and there, and you will be able to move the branch here and there. That's the simple concept of branch. I hope the basic concept of understanding of branch is clear to everyone. Now, what is a head? Head is again a pointer that exists in your Git repository. What head does is, it tells you that what branch you are working on and what's the current commit is. Okay. So it doesn't only just tell you about the current commit. It also tells you about which branch you are actually working at. And now you know that commit is an object. This is, let's say, some commit object. On the commit object, you point using a branch. Branch is a pointer to a commit object, right? And at your current working branch, on what commit actually you are working, or what will be the next commit that you are going to go for, this is actually going to be pointed by a head. So head just do not point to the last commit. It also has the reference to what branch you are at. So just saying that heads points to a commit is technically a half-baked answer, or just saying that it tells you what branch you are at is a half-baked answer. It together tells you about which branch you are at and what commit you are actually going to work with, right? So head is also just a pointer. It is nothing more like more than a pointer, right? And it can point to a branch, and branch is technically pointing to a commit, right? Head points to a branch and branch points to a commit, right? Your head will start moving when you will actually make a new commit to the current branch. Because when the moment you make a new commit, your branch pointer also starts moving. And then if let's say you have checked out a new branch or you have created a new branch pointer, then also your head will move. So let's just see both head and branch in action, and let's see how both of them are actually going to move. Now let's say this is a new project that I'm initializing. I'll do a git init. I'm initializing a new git repository. I'll do git add all. I'll add all of the files. There is technically only one file, new file.txt, and I'll create a commit. I'll say first commit. Okay. If you do git log, you will be able to see that there is something called as head. And as I said, head is a pointer. And what is head pointing to? Master. And what is master having? Master is currently pointing to this particular commit. Let me make one more commit. So let's create a new file. Okay. Let's do git status, git add all, second commit. Now if you do git log, you can see now both master and head are actually pointing to this new commit. That is the second commit. Okay. I by mistake wrote 2st commit. Okay. Cool. Now technically what is going on? What master is currently a pointer that is pointing to your latest commit, right? And head is pointing to your current branch, which is the master branch, and master is pointing to the current commit. Now let's say, what's the use case of branch? Using branches, what happens is you can actually work on a piece of code without hampering other piece of code. Okay. So if you do git log and you do a flag -- graph, okay, you'll be able to see a graph like structure like this, that okay, currently the whole working directory is linear. Now you can create a branch here. Git checkout -b. So the command to create a new branch is git checkout -b. And also before we do git checkout -b, let's copy the commit ID of the last commit. Okay. I'll just print it here. So now we do git checkout -b, and let's give a new name to the branch. Let's say feature branch. Okay, some feature branch we are going to create. So we are now switched to a feature branch. So I have configured my terminal such that whatever is your current branch, you're going to view that current branch directly in the terminal only. Now who defines what is your current branch? Head is going to define your current branch. There can be multiple branch pointers, but which branch pointer you are actually working with is going to be pointed by head. So now if you do git log -- graph, you can see both feature branch and master are on the same commit. So the moment you create a branch, it has not created a parallel timeline for you. It has just created a new pointer. It's just that now there exist two pointers, and now head is pointing to feature branch. See, head points to the feature branch pointer. So whatever will be the next commit, let's say, let me draw it like this. So currently what has happened is you have a first commit, then you have a second commit. Okay, this is the scenario. And previously head was like this, was actually pointed by master, and head was pointing to master. Okay. The moment you do git checkout -b feature branch, what you did was you created another pointer to the same commit named as feature branch, and your head now started pointing to feature branch. So now when you will create another commit, let's say third commit, this third commit will be having the parent as second commit, and your feature branch pointer and head pointer is now going to shift here. Your master is still pointing to this commit, and after making another commit, you are going to shift to this commit here, right? This is something that is going to happen. Let me make another commit. So let's create another file. Let's make it hello.js. hello.js. Okay. If you do git status, you can even see you are currently your feature branch. So your pointer that is actually going to point to the latest commit is going to be the feature branch pointer. If you do git add all, git commit -m, third commit. Now if you do git log -- graph, you can see your master is now pointing to this commit, and your head along with feature branch is pointing to this commit, right? Okay, sorry, I guess I pressed something wrong here. Sorry, my bad. Let's see again. So actually this editor that Git actually opens is called as a less editor, right? We can talk about it, but it's not that relevant. So I just by mistake introduced a shortcut there. So if you currently see, your master is still at this commit and your feature branch is at this commit. And if you see the diagram, you can see still everything is linear, right? It's still a linear structure, right? It's not currently a hierarchical structure has not been prepared technically. Now, if you want to list all of your branches, you can do git branch. Just write git branch and you will see all of your branches. And this asterisk is going to tell you what is your current head pointing to. Okay. If you want to move to another branch, which is already present, you can do git checkout master. Here you can see I have not created the flag -b, so it's not going to create another branch. It's going to just move your head to master. Now, if you do git log, you can see the head is moving to master. So actually you are moving the head pointer. You are not moving actually in the branches. Branch pointer are actually going to exist there only. They're only going to move once the commit is made. When you shift branches, you are actually shifting the head pointer. Now let's say I'll create another file, echo wow.txt. Okay. I'll do git add wow.txt, git commit -m, third commit on master. Third commit on master. You do git log -- graph. You can see currently you are on master. So this is the tree structure that you are getting. Okay. The moment you do git checkout feature branch, now you are in feature branch. The last commit on master was third commit on master. Let's see the git log now. Now you can see you cannot see master here because now master has moved to another commit, which is this commit. Master has now moved to third commit by master. This is the commit object that master is pointing to. And this is the commit object that feature branch is pointing to, right? That's how actually you play it. That's how you're actually going to play with this, right? That's why when you actually now, because there is no linearity, now hierarchy has been introduced. Master is gone to another hierarchy, another sibling. So you can see you don't have any reference of master coming up in the git logs. So I hope this point that actually how your head pointer moves and when you create a branch, you actually create just a new pointer is clear to everyone. So in case you want to visualize all of the branches at once, you can do git log -- all -decorate -one line -- graph. You don't need to go into the meaning of all of these flags. What you can understand is the moment you do it, you will get a graph like structure where you can see all of the branches and all of the commits and the head as well. Now let's say if you create another file in feature branch, for example, wow1.txt, add all, git commit -m, fourth commit on feature branch. And now you do git log -- all. You can see you have this here, fourth commit on feature branch. This is your master branch commit. This is the third commit of the feature branch and so on. So the more branches you will start introducing, the more I would say complex the overall structure will become. So there are a bunch of VS Code extensions. If you will write git, so you can see this is git lens. It's one of the most famous ones from GitKraken. You can install this, right? It says welcome to GitLens, right? And if you have to do the setup, you can see, 1 second. You can see there's a source control view. So let's go here. So let's say if you go to source control, and if you want to see all the branches, you can see you'll be able to list all of the branches here, right? If you want to see all of the commit details, you will be able to check it in the commits view. You can see this is the commits view. If you want to see the commits graph, you can click on commits graph, and a proper graph like structure you'll be able to see here, right? Then you can, as far as I know, you can also see blames. For example, which file change has been made by whom. For example, if you go here and you can see toggle file blame. The moment you do toggle file blame, at every line you'll be able to see this change was made by which author in which commit and everything. You'll be able to see all of those details, right? So Git Lens is technically a very powerful tool that you can find in the VS Code extensions. You can see a lot of things. There's concept of tags. I'll talk about tags. You can even see your stashes. So let's try to visualize a stash. So let's create a new file, wow2.txt. Git stash minus include untracked, save, added wow2.txt. Now when you do this, I believe, let's refresh the stashes. 1 second. If you do, oh sorry, this didn't apply the stash, right? Okay, because I did the wrong command. This flag should be present after save. So git stash, save, and then we need to give the flag. Okay, you can see saved the working directory. And now if you go here and if you go to stashes, you can see we have a stash here. If you want to see the stash details, you can actually see what details you're having in the stash. So it's a cool, powerful, I would say, extension, Git Lens. You can visualize it. A lot of things you can do. To be very honest, I don't generally use it because most of the things I do with terminal. But if you are new to Git, this can be pretty useful. Now let's say if you want to see where your head is pointing to, one way is you do git log and you can see where your head is pointing to. There is one more way in which you can see where your head is pointing to. So if you see the .git repository, inside .git repository, you have a refs of heads. You can also see your stashes, and there is something called as tags. I'll talk about tags later. But if you see, there is something called as heads that is going to represent all of the different branch pointers. But apart from that, there is something called as a capital head. This file, if you do cat.git/head, you can see it is actually currently referring to the feature branch. The moment you do git checkout master, that means now you're moving your head to the master pointer. You're going to actually print master here, right? So this is something that is pretty cool. And if you will always visualize branches with respect to pointers, you're going to get very less issues. So a lot of people think about what is the use case, a production use case of branches. So when you will actually go to production level code, then it's not like you will be having always access to the master branch. So generally people keep different naming conventions. So what people have is, people have their production branch. They call it as main, master. They can give it any name. Then when you have to actually work on a particular feature of a particular service, from a particular latest commit, most probably, you are going to start another branch, your corresponding feature branch. That feature branch can be something, let's say you want to add a click button. Add click button. Something, some feature branch you are going to create, and you are going to work on that feature branch. Parallel to all of this, as I said, like in order to understand the concept of branches, that parallel timeline things work very well, right? So in parallel to all of this, there is a test branch that exists. So when you actually complete your feature branch, it's not like you directly bring your code back to the production branch, right? There is a concept of merging. I'll talk about merge of changes, but it's not like you are going to merge your feature branch directly here. What happens is there are a bunch of feature branches that are going on. Let's say 3 developers are parallelly working on 3 different features. What they're going to do is they are going to first test their changes in the test branch, right? Once the changes are done in the test branch, like this test branch will be having a separate test environment, it will be having separate config variables and everything, then only you will be able to actually merge your code in the production branch. And technically merging doesn't happen directly, right? I'll talk about a concept called as cherry picking, right? So this concept is important before we actually understand how finally all of the features get pushed in the production branch. But technically the main use case of branching is that you will be able to parallelly work on different features without affecting your main line. You are not affecting your main line. You're parallelly working on something else. If let's say you are not able to do something properly, you can just delete this branch altogether. There is, I guess, a command git branch -d and then branch name. It will delete the branch altogether, right? And it will not affect the main line. And generally you are not allowed to directly push anything to the production branch. Like you can keep settings that nobody can directly push to the production branch unless they have a specific right. Right. So this is something which is a very useful use case. If you have ever worked in an internship or any startup or any company, you must have seen a similar scenario there as well. So this is one of the biggest use cases of branches in Git. So now in Git, there is a concept of tags. So if you will go to a repository and try to visualize the .git folder, you will see there are a bunch of tags like inside the refs. These are reference pointers. All of the reference pointers are mentioned like heads and everything. So you can see there is something called as tags. So what is a tag? Tag is also a pointer. In simple terms, tag is also a pointer, right? Tag can point to a particular commit. Tag can point to a particular commit. Let's say tag 1. This is also a pointer. It can tag to a particular commit, and you can store some metadata inside tags. You can store some metadata. The metadata, you can store a particular message apart from the commit message, author details, dates, and everything. These kind of details you can store inside the tag pointer. That's not technically applicable to branch pointers, right? Now you might be feeling that then what is the difference between a tag and a branch pointer? Both of them are a pointer, right? So that's where the fundamental difference between tags and a branch comes into the picture. When you actually make another commit, when you make a new commit, right, your branch pointer actually moves to that new commit. Your branch pointer moves to that new commit. But if you make a new commit, the tag pointer never moves. Tag points to the same commit where it was earlier pointing. So if you create a new commit, tag doesn't change, right? So let me show you. So currently if you do git log, you can see we are on the master branch. Okay, cool. You can create a tag. You can create a tag. Let's say git tag. Okay. And then you can give a name to the tag, for example, -1 tag 1. Okay, so it's giving you a bunch of flags. I guess we need to pass a bunch of flags. One second. If you want to create a tag, you can do something like git tag -a, right? And then you can give, let's say, v1 and then -m tag 1. Okay, you can see now we have created a tag. So if you want to see what is -a actually doing, then you can see here. So it's kind of like an annotation, right? If you want to give an annotation version, then you can do that. And -m also you must be able to see it's a message. So every tag can have a particular message, and there can be a particular annotation that you can also do. To be very honest, I am not sure what's the actual use case of an annotation, but if you want to create a tag like this, you can create it. If now you do git log, you can see the tag v1 is coming. See, so annotation is technically like a tag name, and there can be a custom message to the tag. Okay, technically you can keep both of them same also. That's why I said I don't know what exactly you would like to do, but if let's say the description or the message of the tag is very long, then this v1 can be a tag name. So how do you create a tag? You do git tag -a, put the tag name -m, and give the description of the tag. Tag name and tag description can be same or different, whatever you want to keep. Now let's say I make a new change, or before that, let me show you. So currently tag is pointing to this commit, head is pointing to master, and master is also pointing to this commit. Let's do echo hi. Let's create a new file, hi.txt. I'll do git add all, git commit -m, added hi. If I do git log, now the interesting part. The moment you create another commit, your head and the branch pointer moves to the new commit. Because your branch pointer moves to the new commit, head points to the branch, so head also moves. But your tag pointer remains as it is. This is something that is interesting, right? So your tag pointer doesn't move with a new commit altogether, right? So now if you can do tag show v1, right? Git show v1, and you'll be able to see what is the tag pointing to, which commit the tag is pointing to, right? You can see the tagger name, who tagged it. You can see the date, you can see the tag message, you can see the commit, you can see the diffs in the commit. So this is something important, that let's say if you want to name or tag a particular commit, which is very important, you can give it a tag, right? If you do something like git show ref -- tags, you can see it will help you to list all of the tags. So currently you have a v1 tag which points to this particular commit ID, right? So tag is technically useful if you want to label a particular commit which is technically very important or something ignorant, something special than other commits. You can mark it as a tag. It is going to be a different pointer because it is not going to move once you create a new commit altogether.
So that's it for this particular video. I hope you guys enjoyed the session and you were able to learn a lot of new concepts around Git. If you have not yet checked out algocamp.io, I would highly recommend you to check out AlgoCamp, because we have launched some very cool and awesome courses around software engineering and tech. That being said, let's just wrap this video here. If you have any thoughts, any comments, any feedbacks, don't forget to drop all of those in the comment section below. If you enjoyed the video, then please drop a like and do subscribe to the channel. We'll meet in some other video. Till then, take care guys. Bye-bye. I'm Sanket Singh signing off.